Bioenergentics, it is defined as the flow of energy in a biological system. It is a conversion of macros into biologically usable forms of energy. And by macros, I mean like carbs, proteins, and fats. There are different types of breakdowns, such as catabolism, which is the release of energy, and anabolism, which requires energy. Catabolic reactions are termed exergonic, since they are energy-releasing actions. Anabolic reactions are termed entergonic, since they require energy. Bioenergetics, it goes through 3 different phases. There's glycolysis, which occurs in the cytoplasm of the cell. There's the Krebs cycle, which occurs in the mitochondria of the cell. The last step is oxidative phosphorylation. So starting off with glycolysis, it's basically cutting a glucose molecule in half. A glucose molecule has 6 carbon molecules in it. The 6 carbon gets broken into 3 carbon, 3 carbon. Those sets of the 3 carbons are called pyruvate. If it was an anaerobic reaction, we will end up with lactate. If it's an aerobic reaction, we go to the Krebs cycle. Also, just to point out, in glycolysis, we get a net of 2 ATP. So going into the Krebs cycle, which again occurs in the mitochondria of the cell, we start off with the pyruvate, which is the 3 carbon molecules. Oxygen is released, so we end up with a 2 carbon molecule. This 2 carbon molecule is called acetyl-CoA. Acetyl-CoA and oxaloacetate are going to combine. This will make citric acid, and citric acid will be a 6 carbon molecule. After the citric acid, it goes through a cycle. This cycle, carbons will be released. We get NADH, and we also get FADH. So as we go through the rest of the cycle, like I mentioned, we're going to give molecules a bunch of energy, and that energy is going to be phosphorylated. This phosphorylation occurs in oxidative phosphorylation. Also, I want to point out, in the Krebs cycle, we get a 2 net ATP. So for oxidative phosphorylation, all of the molecules from the last 2 processes are oxidated here. Once they're oxidated, we end up with 38 ATP net molecules.